Okay, here we are beginning chapter 1, section 1 in transition math. Um, I have given all of you, through delivering to your labs or your teacher's mailboxes, a packet of all the notes for chapter 1. So it's all right here, and then at the very end is also the test review for chapter 1. So make sure you get this from your lab teacher or have your lab teacher check their mailbox to pick this up. So that's really important. It goes right along with all of my presentations. Now, of course, I'll post the PDFs up there on Classroom. So if you want to print this one out because maybe you don't have it, you could go ahead and do that. But in the future, try to get your hands on this packet. I do have some extras in my room, but all your lab teachers should have them with your name on it and everything. Okay, let's get started here. So I'm going to be running my iPad here while you can also see me and I can see you. Well, not really in this scenario. So let's get started here. Module 1, Section 1. So, by the way, I meant to tell you that a lot of this material is review, and some of you are going to find it painfully easy. Some of you, maybe it's new to you in some regards, or you've just never thought of it this way, I guess is what I mean. So I'll be teaching it on how, I like to teach it and how I like to think about it and how I think is best even to think about variables and expressions and how to not struggle with this stuff and think about it as something abstract out there. But you guys can do this. All right. So what do you see here? You see 5 apples, right? 5, it represents in a way the number 5. Okay, what do you see here? Well, you see a basket, so then I might ask you, okay, so how many apples are there? Well, let's assume that we stuck those apples inside the basket. So how many apples do we have? Well, still 5, of course. We still have 5 apples. Now, how many apples do we have now? How many apples? Well, I think you all can count, right? 5 plus 5 plus 5 is 15, or 5 times 3. 3 groups of 5, it's all the same. I like you think of it as 3 groups of 5, or 15. 15 apples. All right, so we got 15 apples here. All right. All right, got a new pencil to go along with my iPad, so I'll just try and get it working here. So we got 15 apples that were hiding in those baskets. Now, what if we've got a whole bunch? What if we have a whole bunch of apples in a whole bunch of baskets? And maybe we don't even know how many baskets are there. So what if there's X baskets? We'll just call it X for now. It's a number that we don't know, but we do know that there's 5 apples in every basket. That's given to us, 5 apples in every basket. So what is the pattern here? Don't we always take the fact that we have X groups of 5? So we end up multiplying, just like we did 3 times 5 in the last one. So we have X groups of 5. So on the next slide here, I ask, okay, so if that's true, then what is the expression? Well, of course, you saw it written earlier. It's going to be 5x. Now, we don't usually write x5. That's a car. That's a nice BMW. We write 5x. You always put the number before the variable. Okay, there are some terms that we need to know, and you should have heard all these things before. All right, and they are labeled here. So the coefficient is the number out front. So that's a constant. The coefficient is usually a constant, and it's written out front of the variable. It's usually written out front of the variable. And then we also have an operator, possibly. In this case, we have a plus sign. You might have a multiplication sign. And then at the end of this expression, sometimes you might have a thing called a constant. All right, kind of like I'm constantly talking. It never stops, it never changes, right? These are numbers that don't change, like pi. Pi is considered a constant, even though we use a fancy Greek symbol for it, it's still a constant, it doesn't change. So in this problem, we have 7. That was actually a constant and it was a coefficient. And at the end, we have a constant of a 2, positive 2 sitting there. We're now going to write expressions. That's one of the goals of this section, one of the primary goals, actually. So let's go through the data here. Now, whenever you're presented with several sentences, I want you to just take a deep breath and just read it slowly, carefully, maybe even a couple times, underlining the important information as you go. All right, Steve mows lawns. Now, it's not probably important that his name is Steve. Okay, let's keep going. Steve mows lawns every weekend to make some extra money, and each weekend he has to spend $8 on gas. So it sounds like he has a business and he's spending $8 at the pump. $8. Not $8 a gallon, just $8. Now he charges folks $10 for every lawn he mows. $10 for every lawn he mows. If Steve mows X lawns, write an expression for how much money Steve makes each week. That sounds like profit. Okay, so let's write that down. Profit. Profit is your revenue, money you take in, minus your costs. So let's start with revenue. How much does he make? Well, he makes $10 every time he mows a lawn. Now, that's going to be X groups of 10, right? X groups of 10. Because X is this mystery number that we don't know, or maybe his goal for the week. So we're going to write 10X, just like we did on that previous slide. Now, he does have to fork over $8 in cash each week to pay for, gas. So that comes off the top. That is a cost. So 10x minus 8 would be the answer here. That's called an algebraic expression based on however many lawns he happens to mow. Let's move on. Jose. Jose is 7 years younger than 2/3 of his dad's age. Okay, if Jose's dad is D years old, write an expression that can be used to determine how old Jose is. Now, I want to point out that Jose is younger, so we're going to have to subtract some stuff here. Jose is younger. So we're going to start with dad's age. We'll use D. And then, let me change colors here to help it stand out. Remember it said dad's was 2/3. I'm sorry, Jose is 2/3 of dad's age. So we have to take 2/3 and multiply by D. That'll start with D and make it smaller by 2/3. Okay, so we get 2/3 D. Now, that first sentence said that Jose was 7 years younger. So we still have to minus off the 7 here. So there's the actual answer is 2/3 D minus 7. Now, if part 2 here asks you to, okay, let's use that expression. Let's do a little plugging and chugging. Let's plug in 30 for D. So 2/3 times 30 minus 7. So we can come over to our handy dandy calculator, and I'm going to type. Now remember, you always multiply straight across when you're multiplying fractions. So I'm going to take 2 times 30 and then divide by the bottom, which is 3. And of course, I get 20. So that first part is 20. I minus 7 off of that, and I get 13. Apparently, Jose is 13 years old. And you probably already have that. You're way ahead of me, I bet. I'm just droning on here. All right, we are actually almost done. We've got one more example to do. Find an expression. Now, this is real life. You all have shopped at Kohl's, where it's a big game show. You got to win the game here when you go to Kohl's. Make sure you walk out the door with your hands held high that you beat them at their game. All right. Find an expression that represents the final discounted price after a giant 40% off sale. So let P represent the original full price. So let's do some examples. So if you start with $100, you're going to have to take 40% off. Now, how do you find 40%? You always take 0.4. Remember, you convert the percent to a decimal, and you multiply by the original amount. So I get $40. So $40 is not the new price. $40 is the discount. Again, I took 0.4 times 100, 40. That's 40% of 100. 40% of, the word of means multiply. So 100 minus 40 is $60. So you can get that $100 object or price for $60. All right, let's try 57. This is a little more obscure. Probably can't do this one in your head. So we're going to take 57, and we're going to minus something. Now we come over here to our handy dandy calculator. We're going to take 57, and what did we have to multiply by? The constant, or the coefficient, 0.4 here in our model, 0.4. So that's our savings, 2280, 2280. So then I'm going to minus 57, and I can change the sign or just think about that as being positive. 34.2. $34.2 is the price. 26. We would take 26 minus, come over here, 26 times 0.4. This is our savings, 1369. We're going to minus 26, and we know it's supposed to be positive, so we get 1230 is our savings. So what are we doing every time? That's the formula that's being talked about here, the formula. So what do we put in here? Well, we always start with our original price, and then we subtract off 40% of that original price. Now you could leave your answer that way, or how could we simplify this? Well, what is 1p take away 0.4? That's 0.6p, or 60% of the original is what you're paying. 60% of the original is what you're paying. So that's called an algebraic expression. So this would be the little machine you could use to figure out all the prices in all the store. You don't have to do this subtraction and this 2 or 3 step process. You could just do one step to figure out the price, and you take 0.6 times the price, and bam, you got your answer for how much that sucker costs. All right, this is the end of 1-1. See how, wasn't that easy? All right, so hopefully you filled in your notes, you got your packet from your lab teacher, and then you're going to be able to use that on tests and quizzes, of course. So you want to hang on to that, don't lose it. Now get yourself on Google Classroom and see what kind of exciting activities I have planned for you. All right, good luck.